So good afternoon. Today we will see regarding different types of operators available in Python programming language. So this video mainly concentrate on listing the different types of operators, mainly arithmetic operators. So before going into arithmetic operators, let us see what is an operator and what is an expression and what is the link in between the operators and expressions. So the Python includes various types of operators which can be used to link the values and operands. So if you want to perform some mathematical operation, or if you want to perform some computation or some manipulations using Python, so it is providing us with a different set of operators. So these operators perform different types of the operations. So if you want to perform some normal operations like addition, subtraction, multiplication, division, so the Python provides arithmetic operators. And if you want to have condition checking, so like if you want to know true or false, then in such a case it is providing some Boolean operators, right? So true or false. And if you want to know the relation in between two values, then it is providing us relational operators. And if you want to perform operation on bits, or if you want to perform operations in terms of the values having bits, then in such a case Python is providing us bitwise operators. And if you want to assign a value to a variable, then it is providing us assignment operators. With a simple assignment and compound assignments, operators are being provided by Python, right? So these operators, when you take the combination of operators and operands, the link, we call it as expression. So the combination of operators and operands, we call it as an expression, right? So what is meant by operand and what is meant by operator? So if I consider, for example, 2 plus 3, right? So 2 plus 3, this is an expression. So here this particular expression, when you perform some operation on it, it is giving us an output as 5, right? So here what is operation you are performing? This addition you are performing. This plus, we call it as what? The symbol which performs some operation in between the values, we call it as what? Operator. We call it as operator. And these values where the operation is being performed on, we call them as what? Operands. Operands, right? So this we call it as operator, and these values we call them as operands, right? Python operators include arithmetic operator, Boolean, bitwise, relational operator, simple assignment, and compound assignment operators. So coming to the arithmetic operators, we have the symbolic representations like plus, minus, slash, double slash, asterisk, and modulo. So this plus is used to perform addition, minus for subtraction, slash is for normal division, and double slash is for floor division, and asterisk is for multiplication, and this percentage, this we call it as a modulo, right? Next, operators are Boolean or logical operators. Boolean or logical operators. We have a logical and or not. So why we are calling them as Boolean? Because these will give the output as true or false. So the return value of these operators is either true or false. They are resulting the Boolean values as output. So we are calling and or not as a Boolean or logical operators. right? So in C we used to have logical AND is ampersand, 2 ampersand, logical OR and logical NOT. But here instead of using these symbols, we are using directly AND or NOT. Right? Next is a relational operator. A relation in between two operands is established using these relational operator, which is a greater than, less than, greater than or equal to, less than or equal to. Next we have not equal to. So these mainly, and there is another relational operator equal to. So these mainly specify the relation in between two operands. And next we have a simple assignment equal, and compound assignment is nothing but the assignment operator in combination with arithmetic operators. We call them as what? Compound assignment operators, right? And operators and expressions in this, what is meant by an expression is nothing but a block of a code that produces a result or value upon evaluation. So if I give some expression like 6 plus 3, this expression will be broken down into operators and operands. First, in the interpreter, Python interpreter, it will create some table here where it will store some operators, and then it will create another table where it stores the operands. So the operators will, what are, this is an expression, so what are all the operators we have, it stores here, and what are all the operands we have, it stores like 6 3. Now based upon the operators, it will retrieve the plus symbol and it will apply on 3 plus 6. So the output which we get is a 9. So the result again goes to this particular stack where it stores the result again into the stack on top of the values. Right? So the operator requires the data to operate, and this data is called as what? Operand. Right? So coming to the arithmetic operators, based upon the number of the operators, based upon number of operands, we can divide these arithmetic operators into two types. Based upon number of the operands, we can divide it into two types, unary and binary. If you have only one operand, say 3 or minus 3, so this is a positive 3 and this is a negative 3. So this minus here is indicating the sign, plus 3. This indicates the sign of this particular 3 value. So for this particular operand, only one operator is being applied before it. So this plus is indicated as a sign. Here, as there are only one operand, okay, one operand linked with this one operator, we are calling it as unary assignment operators. Only plus and minus operators can be used as a unary arithmetic operators, right? So next we have the binary operator as arithmetic operator. Binary indicates we have the two operands like 2 plus 3, 2 minus 3, 2 into 3, right? So arithmetic operator having two operands linked, okay, we call it as binary arithmetic operator. Okay, so here we have the 2 and 3 as a two operands. So with the two operands in between, the link is what? One operator is being used, that is arithmetic operator. Either place minus, into, or division, or modulo, any of the operators we can use, arithmetic operator can be used as a binary operator in between the two operands. If there is only one operand, it is unary arithmetic operator. Mainly plus and minus is used as a unary arithmetic operator, whereas all other arithmetic operators like plus, minus, into, modulo, floor division, normal division will be used for binary arithmetic operators. right? So here whenever you are using those operators, we need two operands. That's why we are calling it as binary arithmetic operators. And this is an example for the unary. So we will be using unary operator minus unary operator plus. Why we are calling it as unary? Because it uses only one operand, that is here specifies plus indicates plus x. That means it returns the same value. That mainly it is used to know that it is a positive value. So next I am using minus x. So this indicates that I am using the negative value. So minus indicates negativity, plus indicates the positivity. So this mainly specifies the sign of a specific operand. So here we use only one operator, the one operand to link with the operator. So that's why we are calling it as unary plus and unary minus. These two are considered as unary operators. Next example is like x equal to minus 5. So now when I print x value, what it has given? Minus 5 as output. So x equal to plus 6. Now when I print x, it has given value as 6. So plus minus of 5. So what? Plus minus minus. So output is minus 5. So here plus minus will be considered as expression. So this is expression, right? So this can be evaluated as plus of minus of 5. So plus into minus. Plus minus gives to minus of 5. So when you want to evaluate this particular equation, 1 minus minus 3, 1 minus of minus 3, minus minus plus, so it gives 4 as output. 2 minus 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 3, 2 minus of minus 3, it gives the output as minus 1. Right? So how it will be evaluated? 2 minus of minus minus plus, again minus plus minus, equal to 2 minus 3, that equal to minus 1. Right? 2 plus minus minus 2, this is equivalent to 2 plus minus of minus 2, that equal to 2 plus minus of minus plus 2, plus plus, sorry, 3 plus plus 2, that gives to plus plus again plus, that is 3 plus 2. What is the output? 5 will be the output. Right? Coming to the binary operators, what are all the binary operators? Like arithmetic binary operators, the operators which require what? Two operands. We call them as binary arithmetic operators. First one is an addition operator plus. This is a normal mathematical operation which mainly produces the addition or the sum of two values or two operands. So when you take 4 plus 7, so it will give the output 4 will be added to the 7, output sum is 11. 5 plus 5, the output is 10. So whenever you are using plus operator, so based upon the operands also the output varies. That means if you are adding the integer with integer, it gives the output as integer. If you are adding the float with the float, output will be the float. If you are adding integer with the float, output will be the float. If you are adding float with integer, output will be the float. If you are adding complex with complex, output will be the complex. So integer with integer is like example, 2 is an integer value added with the 4, which is also integer. Output is what? 6, which is also integer. Now float 1.0 is a float. We have a decimal value here, plus 4.0. We have a decimal value here. This is a float and this is a float. Output is 1 plus 4, 5. So we are getting 0.0. That indicates 5.0 is also a float. Float added with the float gives the output as a float. Int added with the float gives output as float. Integer is 1 plus 3.2.0, which will return output as 3.0, which is a float. So this is an integer, this is a float, and this is also a float. 2.0, which is a float, 1 is an integer. So the output by default will be the float. So when you take the integer and the float, as a float is having the more data compared to the integer, the output will always be the float value only. So there won't be any data loss. That's why so integer is also converted into the float. Now it will give the output as a float only. Next, complex number 2j plus 3j plus 2j. What is the output I am getting? Complex plus complex number gives the output as a complex number only. Right, coming to the subtraction operator, so here we will be finding the difference in between the operands. So the difference of two operands will be the output. So if I take 7 minus 4, the output is 7 minus 4 is 3. So it will give the output 3. 5 minus 2, the output is 3. So whenever you are taking the operands into consideration, so when you have an integer subtracted by the another integer, the output will also be the integer. Like 4 is an integer, 2 is an integer. 4 minus 2 will give the output as an integer. This is an int value. Right, so float and the float. So if you subtract a float from the another float, then the output will also be the float. Like 3.5 minus 1.5, where 3.5 is a float, and 1.5 is also a float. A float minus float equal to the float. So the output will be the float value. Right, so int comma float. So this is an integer value and the subtracted value is a float. A float value subtracted subtracted by the integer value will give the output as a float. 4 is an integer and 1.5 is a float. 4 minus 1.5 is a 2.5, which is a float value. Next, float, integer subtracted from a float, it will give the output as a float. 4.0 minus 2 will return the float. So here 4.0 is a float, 2 is an integer, it is giving the output as a float. Complex subtracted from the complex gives output as a complex. 3j minus 2j returns output as 1j, which is a complex value. Right, so a simple example program which is used to find the profit earned by the seller in rupees. Okay, so we have to read the cost and the selling price, cost price and selling price, and based upon that you have to find the profit earned by the seller in terms of the rupees. So here SP indicates the selling price, CP indicates the cost price. Okay, so for the profit, the syntax is whenever you want to get the profit, always selling price should be greater than the cost price. That means the cost price indicates the amount we spend while buying that particular item, and selling price is the amount we are giving to someone else. Okay, so that means the selling price should be always greater than the cost price, then it indicates that we are getting some profit. If the cost price is greater than the selling price, that means if at all I brought the item for 100 rupees and if I am selling it for 90 rupees, then I am in a loss of 10 rupees, right? So that means if at all the cost price of that particular item is greater than the amount you are gaining from it, we call it as what? Loss. Right, so here I need two input values, selling price as well as the cost price. So I may take either integers or the floating values. So that's why I am taking eval. Okay, so based upon my convenient, either I can read the integer or the floating value. That's why I am taking here as eval. Input, enter the selling price. input, enter the cost price. So here in Python, as in the C program, as execution starts from the main, here there is no need of the main function. The execution starts from the starting line of your program. So here it goes from here, it from here it starts the execution. So first it will take the input value. So it will ask an input for the selling price. So for the selling price, so it will be accepting the data. So enter the selling price of an object. So say I have mentioned it as 45 rupees, 45. Now whenever you give the 45, it goes store the data value in the memory on for a specific variable SP. Now it goes to the second line CP, where the cost price is being taken from the user. As I mentioned, the 20, it goes stored in the in the variable space as 20. Right, after that I just printing some line for the decoration purpose. Right, so next, print selling prices. So I want to print what I have read, so I just printing the selling price equal to SP. Now in this particular SP value, what is being stored in the memory, 45. So it go from the memory, it will be read and it will be displayed as selling price equal to 50. Now cost price equal to CP. In the memory, 20 is being stored in the variable CP, so it is being retrieved and it will display as 20. So cost price equal to 20 will be displayed. Now it's time to compute the profit. So what is the formula for a profit? Is profit equal to selling price minus cost price. So selling price is 45 and the cost price is 20. So the profit is 45 minus 20. So what is the profit here? 25 is a profit. So I bought the item for the 20 rupees, but I sold it for 45 rupees. So the I spend only 20 rupees on that particular item while buying, but while selling it I have gained 45 rupees. So total amount which I have gained is a profit. So 45 minus 20, so the amount is 25. So why I am subtracting the 20 is 45 rupees I have sold it. The amount I sold the item is for 45 rupees. So previously I have spent 20 rupees on it for buying it. So the total 45 minus 20, how much I bought? I got 25 rupees as a profit. So now the profit is earned by the selling the particular item is in the profit. The variable profit will be created in the memory where 25 will be stored. Now whenever you are printing profit earned by selling, it will print for the profit, it will retrieve 25 from the memory and it will print 25 for you. Right, this is how the arithmetic subtraction will be used. So here when the interpreter see the minus symbol, it automatically performs subtraction operation on two operands, that is selling price and cost price. Right, coming to the multiplication operator, also which gives the product of two operands. So this is also a binary form. So you can have the two operands here. In between we have the operator, which will give the output as the product. 7 into 4, it gives the output as 28. 5 into 2, output as 10. Right, so here also when an integer is multiplied by the integer, it gives the output as int. So 4 is multiplied by the 2, output is 8. Float multiplied by the float, it gives the output as float. 1.5 is a float, 3.0 is a float. So when you multiply these two, you will get the output as 4.5, which is a float. Int multiplied with the float gives the output as a float. So 2 into 1.5. 2 is an integer, 1.5 is a float, output is a 3.0, which is a float value. Right, so float multiplied with the integer, it gives the output as a float. So 1.5 is a float value and 5 is an integer value. So 1.5 into 5, which is 7.5, which is also a float value. right? So next, complex multiply the complex, which will return the complex value. So 2 into 2, 4, j into j, j square. So j will be taken as square root of -1, imaginary part. 2j into 2j, which gives the output as 4j square. That is what? 4j square is root of -1 whole square. That is 4 into root, square root cancel, -1, that is -4, and there is no imaginary part, so it will take as 0j. This is how we got this, right? So the program calculating the square and the cube using what? Product or multiplication operator. So the just I need to read a number, num, which is used for reading the number variable. Num is used to read the number or to store the value. Here I am reading the value into the num, right? So whenever the interpreter goes here, it will create a space for it, num, right? So eval, so whatever the value you want. So normally for calculating the square and the cube of a particular number, you will be taking the integer value, prefer taking integer value but not the float. So initially 0 will be stored here. Now print number equal to num. So just I have read a number called as a 5. So here 5 will be stored. Now print num. So in the memory for the num, 5 is being stored, it will be retrieved, and here it will print as num equal to 5 as output. For the num, 5 will be retrieved and it will display like this, number equal to 5. Now square is a variable which is used to store the square of value. That means num into num. So it will store the value for the num 5 into, again for the num 5 will be retrieved from the memory. From here it will be retrieved and it will be stored here. 5 into 5, 25. Now it will store 25. And next for the cube, it will create another variable cube and space will be allocated. Now it will take 5 into 5, right? So what 5 into 5, 125 will be stored here. Now whenever you are printing square root of a number, num, for this num 5 will be retrieved, and is for the square what it has been stored, 25. So it will be retrieved and it will display like this, square of a number equal to 5 is 25 will display. Cube of a number equal to 5, for the number it will retrieve 5, and for the cube 125. So it will display cube of a number equal to 5 is, for the cube 125 will be retrieved from the memory and it will display the output, right? So for calculating the cube, square, for calculation of any product, you need use of this multiplication operator, right? Next is a division operator. So here this is also a binary form where it returns the result of what? Quotient value. So whenever you go with the division, so you will be taking the quotient value. This is a quotient value. This value we call it as what? The output of this particular division is this quotient value, and here we have the remainder. So dividend, divisor, this is a dividend, divisor, dividend, quotient, remainder, right? So first whenever you take an example 4 by 2, so 4 will be considered as a dividend, divisor is 2, so 2 2's a 4, output is what? 0. So now what will be the output of this 4/2? The output is, what is the quotient I got? 2. So 2.0 will be the output. If I take 10 by 3, so 3 10 will be divided by 3. So what I get? 3 3s are 9, right? 1.0, 3s are 9, 3. Next I 3 3s are 9. Next what I got? 1 0. Next 0.01. Again 3s are 9, again 1 0, up to so on it goes on, right? So the quotient which I get will be the output of this particular operator division. So the same when you have the integer by integer, like so 25 is an integer divided by 5, which is also integer. Output is what? The float value. So integer divided by integer, the output of all these particular division will always be the float values only. So numerator, denominator. So the numerator is 25 by 5. We have the output as a float. Int by int gives the output float. A float by float. Float divided by float gives the output as a float. Next, int divided by a float gives the output of float. Next, float divided by int give the output of float, right? So complex by complex gives the output as complex value only. So like 6j by 2j. So this 2, 6 by 2 is 3. 3 plus 0, j will be the output, right? So it will return the quotient as float value, right? This is a simple program which is used to calculate the simple interest. So the simple interest formula is simple interest equal to PTR by 100. P is a principal value, this is a time, and this is a rate of interest. So the principal value, time taken to pay the amount, and this is an interest, right? So by 100 this will give the simple interest. And so we have to read in the problem statement is like calculate the simple interest SI, read the principal as well as rate of interest, that is principal is P, rate of interest is R, and number of years is T. So PTR by 100, right? So first we have to read the P value. So maybe taken in terms of the integers. So eval input of enter the principal amount. So for the P, what I have read, some 1000 rupees I have read. So in the interpreter will store this in the memory. P will be the variable name and 1000 is the value I have read, so it stores here. Now ROI is another variable where it stores a rate of interest. So I have taken rate of interest as 8.5, which is a floating value. So my interest, so that's why I have taken eval here, right? So number of years, so for that it has created the variable called as years. So number of years I have taken as 3, right? So printing these values which I have read, so principal equal to, from this 1000 will be retrieved and it will be assigned here as 1000. So principal equal to 1000. Next, rate of interest ROI, so 8.5 will be retrieved from the memory. It will display as rate of interest equal to 8.5. Next it goes with the print number of years. So number of years is a 3, so it will retrieve from the memory 3. It will display number of years as 3. Now I need to calculate the simple interest. The formula is PTR by 100. So here I am using the division operator. So what is the P value? 1000 into rate of interest is 8.5 into 3 by 100. This will be cancel. 85 into 8.5 into 10 is 85 into 3 is a 15 and 24 25.0. This will be the output, right? So now this will be stored in where? This will be stored in simple interest. Now when you print simple interest, for this SI 255.0 will be retrieved and it will display here. So when you want to calculate this the same, it will be following this particular operation will be performed by this symbol, division symbol, which will give the output as quotient value, right? So the another program is to read the temperature in Celsius from the user and want to convert it into what? A Fahrenheit. So here you will be using the formula as 9 by 5 into Celsius plus 332. For Fahrenheit equal to 9 by 5 into Celsius plus 32 is a formula for calculation. Here it will convert this 9 by 5 into 9 will be divided by 5. 5 ones 5, 4.0, 8's 40, 0. Right now 1.8 will be taken and it is being multiplied with 23 and this value will be added with 32. So 23 8 point, so how it will be calculated? 1.8 24 8 to the 16 plus 2 18 23 4 next 11 next value is 4 41.4 32, that is 73.4 will be the output, right? So the first this value will be calculated, this quotient will be multiplied with 23 and then added with 32. So I am taking the Celsius from the user. So the Celsius value may be integer or some decimal value. So I have considered eval. So when print Celsius, now Celsius I have considered as 23. So Celsius will be created, variable will be created. Here 23 will be stored. Now when you print Celsius, 23 will be retrieved and it will display like this: Celsius equal to 20, Fahrenheit equal to 9 by 5 into Celsius plus 32. Now for this Celsius again 23 will be retrieved and here it will give the output Fahrenheit. The Fahrenheit value is 73.4. Here when you print it, for this Fahrenheit value 73.4 is retrieved from the memory and it will print that particular value, right? So this is how you can use a division. So next division is a floor division. As we have seen the previous division, it is been giving the output as float value only, right? So in this floor division, instead of getting the quotient value as a float value, here it will give the quotient value, that means the result, as an integer only. So int by int it will give the integer, a float by float it will give the float, int float it will give the float, float int it will give the float. So 25 floor division. So the normal division, floor division. So this is how. So integer 2, if I take this particular, there it has given like 3.3333335, right? But here what it has given the output as 3. So this is how the floor division works. So it will return the output, the quotient value integer when the dividend and divisor are integers, right? This is an integer which is divided, a floor division by integer, it is giving the output as integer. And the float, which is a floor division by float, which gives the output as a float. Int floor division by float, floor division by float, it gives the output as a float. And the float floor division by int, it gives the output as a float only. Okay, so in this case it has been changed. Instead of giving the float as output, it is giving the integer as output, right? So Python returns int result when two integers, when the two operands are integers, where when applying the floor division, right? So modulo operator, which is also a division operator, which will retrieve only the remainder value. So normal division will quotient value, this will return quotient, and floor division is also a quotient. Here it will retrieve only the float as quotient. Here it will return int as a quotient. Now int as quotient. Now this is a floor division this is a modulo which will return the remainder value, remainder as output, right? So modulo will return the remainder value. The modulo operator returns the remainder value. So we can even call it as what? Remainder operator. The other name is remainder operator. So the dividend divisor, this is what we get from this particular operator. So when you go 14 modulo 4, so 14 modulo 4, this will return the modulus, so the remainder. So 4, 14. So 14 divided by 4, it gives as output as 2, which is the remainder. So this is the output of modulo, this is the output of division operator, right? So same, so integer modulo integer gives the output as integer. So 25 modulo 4, so this is an integer and this is an integer which we are getting the output as integer. A float modulo float, this is a float value and this is also a float value, we are getting the output as what? A float. Integer float, so integer modulo float, this is a float value which we are getting the output as what? A float. And next float integer, so the float value modulo integer gives the output as a float. Only in terms of integer modulo integer we are getting integer, and in other ways we are getting the float as output, right? So how this is being evaluated? So this is a simple example. 14 modulo 5, so equivalent to x modulo is equivalent to x minus y into x floor division y, right? So this we have to solve. Example has been given as 14 modulo 5. So normally 14 divided by 5, 2s are 10. What is the output we got? 4. This is the output, right? So now what we have to take here, whenever we consider the same here, refers here, so x will be considered as 14, y will be considered as 5. 14 modulo 5 equivalent to x value is what? 14 minus 5 into x is what? 14 floor division what? 5, right? So here we have to follow the BODMAS rule. First within the brackets we have to solve 14 floor division by 5 means what? So what is the quotient I got? 2. So this is an integer and this is an integer. The quotient is also should be integer. 14 minus 5 into what is this? 2. Now we have to first minus and into the highest precedence is what? BODMAS. Division brackets of division, multiplication, addition, subtraction. So the multiplication is given preference. So the second preference is multiplication. 14 minus 10. So what is the output we got? 4. Is this the same? 14 modulo, that means 14 modulo 5 is 4. This and this is same, right? So we can say that x modulo y is equivalent to x minus y into x floor division y. So this is true, right? So the simple example program which is used to convert the whatever the weight we have given in terms of the grams, we have to convert it into kgs and the grams, and we have to display it. Say if at all I have given the enter the weight of an object in grams is 2500, now it has to convert it into kilograms and grams. That means 2 kgs and 500 grams it has to print. So for that what I have taken, first W1, which is a weight that has to be taken as weight of an object that is to be read from the user. So I have considered a val input enter the weight of an object. So here W1 I have considered the weight as 1250. right? 1250. Now print weight of an object. For the W1, what it takes, so from the memory it will take this 1250 and G is being suffixed to it, and it will print as 1250 grams. It will print like this, right? So now I want to calculate number of kgs. So the 1 kg equal to what? 1000 grams. So I have considered 1250 grams equal to how many kgs. So that's why what I am doing, W1 floor division 1000. That means 1250 by 1000. So what I will be getting, so ones to 12 ones, sorry, 1000 ones 1000. So what is the remainder I got? 250. And what is the quotient I got? 1. So in W2 what I am storing? 1. Next in W3 what I am storing? The remainder, modulo operation I have applied. So I am storing the 250 value. Now weight of an object, W2 kgs. W2 is what? 1. So the 1 kg. And what is the W3 value? 250. So 250. So 1 kg and 250 grams will be printed as output. So here this is how you can use this modulo as well as the division operators in the real time, right? So this is a program for reversing a 4-digit number using modulo and division operators. So if I take a number like say this is an example number, so I have considered a number like 1 2 3 4. The output should be like 4 3 2 1. So first initially I need to get the 4 value, next I need to get the 3 value, next to 2 value, next 1 value. So one by one the last digit is to be removed. So if I want to get the last digit of this particular number, what I have to do? 1 3, the number should be divided by 10. So what is the output? 1 12 the 120, next 3 34, 3 is 30. What is the remainder I got? 4. So this will be the first value. Next again I need to consider this 123. Again I need to take, so first remainder is taken for the result. In the result we will be storing first remainder. Next the quotient will be considered as an input, and it is again divided by the 10. Again we will be getting 12 120. Now remainder is 3. So the 3 will be taken, it will be stored in the result. Now again this 12 will be taken, it will be divided by the 10. Right? So the quotient value and the remainder value has to be considered. So we have to perform the modulo as well as division operator. 1 is 10. Now this is a 2. So the 2 will be taken here. Next we have the 1. So 1 by 10. So we will be getting 0. So 0 won't be considered. So what is the output? We have 1. So that will be considered as output. So 4321 is the result. The same way here we will be using the same. So here number equal to num equal to eval, input enter 4-digit number. So the first for the num value I have considered the value as, what is the input I have given? 8763 is the input, right? Enter number. Now it will print the number as 8763. Now it goes with the calculation purpose here. Okay, so what it do? R1 equal to, so in the R1 what it will store? So 8763 by 10. What will be the output? 8's 80, 7's 76, 7's 70, 63. So 6's 60. So what will be? So in the R1 remainder it will store the output as 3. Now for the quotient value, right? So num is what? 8763. So what is the quotient I got? So what I am performing here, floor division, so it will give the output as a integer. So what it will store? Q1 will store the output as 876. Now in the R2, right? So what is R2? R2 equal to quotient 1 Q1, that means 876 by 10. What 8's are 80, next 76, 7's are 70. So what is the remainder I got? So R2 equal to, so this is again, this is divided by 10. Now what will be the output? This remainder 6 will be the output. Now what is the quotient value I got? 87. So this is in Q2. Now R3 equal to Q2, that means 87 modulo 10. So R3 equal to, so 87 modulo 10. So 8's 80. So what is the remainder I got? Here the value is 7. Next Q3 equal to Q2 floor division 10. So what is the quotient I got? Q3 equal to 8. Next Q4 R4 equal to Q3. What is the Q3? 8 modulo 10 equal to, output will be 8. When you have the numerator value less than the denominator and applying the modulo operator, then in that case numerator will be the output. When you are applying the modulo in between the two operands, if the numerator is less than the denominator, then the output will be the numerator only. So the reverse of a number is, so R1, R2, R3 and R4. This is the result of the reversing of a number, right? Coming to the next operator, arithmetic operator, is exponential notation. So here when you want to perform some cube, so cube of a number, so how you do? Say for example 2 cube. So you will be taking 2 into 2 into 2 and then you perform, you will get output as 8. So you have to use 2. If you take like 2 power of 5, so then in such case 2 into 2 into 2 into 2 into 2. So number of times you are using is 4 times, like that. So based upon the power, the number of multiplications increases. But here in Python, in order to avoid the multiple usage of this particular asterisk symbol, we have an exponential operator called as, which will be represented as 2 asterisk symbols. So if you want to perform the cube of the 2, just you can use 2. What is the power you want? 3. If you want to perform the 2 power of 5, 2 double asterisk 5. So this indicates the operand and this indicates the power. Operand, power. So if you want to perform the 5 square, so 5 into 2, this indicates the 5 square, this indicates the 2 cube, this indicates the 2 power of 5, like that. So the power will be after this particular symbols, 2 asterisk. So it is like x power of 5 will be written as x exponent y. So this is a exponent operator, into 2 asterisk, double asterisk, right? So here also when you have an integer value as a power, it will give the output as integer. So integer to the power of integer, it will give the output as integer. Float to the power of float will give the output as a float, and the integer to the power of float will give the float value, and the float to the power of integer will give the output as a float value only, right? So simple example is calculate the distance between 2 points. Distance between 2 points. Here we have the formula x2 minus x1 whole square plus y2 minus y1 whole square to the power of square root. So square root can be taken as x2 minus x1 whole square plus y2 minus y1 whole square to the power of, we will be considering square root as 1 by 2. So this 1 by 2 will be replaced with 0.5. So here now how you can calculate x2 minus x1 into so what is the power? 2 plus y2 minus y1 exponential into 2 this to the again what is the power I need? 0.5. So this is how you can calculate the power distance between 2 points using the power exponential operator. So I am taking the reading the 4 values. So first point is x1, y1 is the first point. This is a point. So sorry, x1, y1 is a point, and this is x2, y2 is the another point. I need to count the distance in between these 2 points. This is a distance. So this is the x coordinate of first point. This is y coordinate of first point. Second, this is a first x coordinate of second point. This is y coordinate of second point, right? So so first I have considered as x1 and y1. For the x1 I have taken 4, and for y1 I have taken 6, and for x2 I have taken 8, and for y2 I have taken 10, right? So now what I have considered reading the values of x1 and y1. So when you read the values, 4 is read to x1, 6 is read to y1, 8 is read to x2, and 10 is read to the y2. Now L1 is a calculation distance between the 2 values. First inner, so the length, that means this is mainly used for storing the value of inner side. So this value is being calculated as L. Okay, L1, right? So L1 equal to, so x2 minus x1, so x2 minus x1, this value, plus y2 minus y1, this is all I have considered it as what? L1. And next I am exponenting with the 0.5. Now L1 equal to x2 minus x1 double asterisk, that means exponential 2 plus y2 minus y1. So what it will be like, x2 minus x1 whole square plus y2 minus y1 whole square. This is what is being calculated, and it will be stored in the L1. So x2 minus x1, that means 8 minus 4 whole square plus 10 minus 6 whole square. So 4 square 16 plus 16, that means 32 will be stored in L1. Now 32 into that means 32 to the power of 1 by 2. So it will get the output as 5.65, so on. Okay, so the distance between 2 points is as follows. It will print the distance as 5.6. So for this x1, thus 4, for the y1 6, for the x2 8, for the y2 10 will be retrieved, and it will print 4 comma 6 8 comma 10 equal to 5.656, so on, right? Thank you.